Many of us have seen sort of the very damaging effects of chemotherapy. To get enough drug into the tumour, we have to have a large amount of drug going around the body. That causes a lot of collateral damage, a lot of toxic side effects, so it's unpleasant for the patient, and it restricts the amount of drug that we can actually use. So if we could trigger the release of those drugs only at the tumour site, then this would have great potential benefit. The Horizon platform is our prototype instrument for making microbubbles, and this was designed here in the School of Physics and Astronomy. This is the only instrument in the world that could make clinically relevant concentrations of microbubbles. These are 1/100th of the dimension of a hair. We can inject them into the bloodstream and they go around the body just as the rest of the blood does. If we image at the same time using ultrasound, we can actually see in the ultrasound images where these bubbles are, and that includes if they were to perfuse into a tumour site, we would see the bubbles building in that tumour site. So in Leeds we want to target the ultrasound signal to the tumour site such that when bubbles, which we now would load with our drug payload, are passing through the tumour, we can actually locally disrupt or burst those bubbles to release the drug. I believe we're between 3 and 5 years away from getting these into patients. In the future we will look back and wonder why it took so long to combine drug delivery with physical mechanisms to enhance that uptake. What people could really help is speed that translation process. We need to recruit people to help us improve on the engineering side, the design of the instrument, that it would be suitable for clinical application. We also need people to test these drugs in a preclinical model, and that would allow us to say this is an efficient methodology for the treatment of cancers.